We are doing the topic of uncertainty, and we are starting with our first concept for today. If uncertainty is given in percentage, it can be directly written as a fraction. Percentage actually means fraction. You have to copy this screen.
Okay.
Let me know once you have copied it.
Done, sir.
Done, sir.
So this is our first concept for today. Uncertainty is actually calculated to use the level of accuracy. We discussed this concept in our last class, that uncertainty always aggregate, always sum up. It means that in every successive calculation, uncertainty does never decrease, it always increases. Now I'm putting my second concept for today. Uncertainties should not be subtracted, should not be raised to a power, should not be subjected to a unit conversion. They can be subjected to unit conversion, but normally avoid it.
Okay.
You have to copy this screen.
Done, sir.
Done, sir.
We already had mentioned in our last class a very important concept, that uncertainty is always correct to one significant figure. Now, our third concept for today, when you are doing the calculation on uncertainty, it is better to modify a formula rather than a given value in case of uncertainty. For example, look at this example. Diameter is given 20 plus minus 1, and we want to find the area. The formula which is famous is area is equal to pi r square. In O level, what we used to do, that we will convert diameter into radius. That will change the 20. But I have to change 1 also. Now, this is a very technical issue, that if you halve 20, you cannot halve the uncertainty, because uncertainty is coming from the system. Like if your stop clock is 5 minutes ahead, 5 seconds ahead, it will remain at 5 seconds, whatever you read, because it is not the case of the number. So if you want to convert the diameter into radius, you will divide by 2. Now you can divide 20 by 2 and you can get it 10. But the problem is, how should I divide 1 by 2? Because it will change the uncertainty. Uncertainty is not a number alone which can be divided by 2. It means if diameter has an uncertainty of 1, it is not sure that radius will also have a diameter of, radius will have a uncertainty of 0.5. So my third concept, it is not good to change the numbers. It will be ideal that you should not take this route, you should take this route, and you should modify the formula rather changing the data in the question. Now you have to copy the third concept for today.
Done, sir.
Done, sir.
Now, there are two possible routes. Radius is equal to d upon 2. Radius is equal to d upon 2. Option 2, change the formula. So, it is better to change the formula rather than dividing 20 by 2. You have to copy this example.
Sir, can you explain like how the
Actually, what I tell you that this topic, uncertainty, is a numerical topic. And you know, all numericals need questions because we have to make proper notes in A level. So I'm making that. And after that, we have to do questions on them. Actually, this is a concept of calculation, that there are two possible routes. One is there that you divide 20 by 2 and you proceed with the calculation. This will make a problem because how I will tackle one. Second option, do not alter the diameter, change the formula, and within the formula, put the value as it is and then solve for diameter. This is the second approach. So option 2 is better because it will not be requiring the change in uncertainty. Constants are ignored. Our fourth concept for today, constants are ignored in uncertainty calculation, because when you say constant in English sense, in our English language, the word constant and word uncertainty cannot go together. When you have a number 2, there is no uncertainty in it. But when you say X, it can have an uncertainty. Constants are ignored in uncertainty calculations. You have to copy now this concept.
okay, sir. Done, sir.
For example, when examiners say pi d square upon 4, 4 and pi are constant. So we will not consider them in uncertainty calculations. We will consider only d square. You have to copy this screen.
Done, sir.
Now, give a heading, uncertainty calculations.
Done, sir.
I'm putting the first calculation is sum and difference. So give the heading uncertainty calculation and then give a side heading sum and difference. Now I'm putting the formula as I was answering Saad, that when you do a code topic which is purely numerical, we first make the rules, we do some questions with it, but actually this topic will grow. And this is the most important topic of this chapter. This topic will grow when we start the past paper. We do the questions on this topic. Now, you see the formula. If u is equal to x plus y, then deba u will be equal to plus minus deba x plus deba y. If you add two numbers, their uncertainties are also added.
Okay.
You have to copy this. So what is the concept? If two numbers are added, if two variables are added, their uncertainties are also added. The rule says when two variables are added, their uncertainties are also added. Look at the example. I have a mass M1, 20 plus minus 2. Second mass is 30 plus minus 1. And I want to find the total mass. Total mass will require to me that I have to add the numbers. Now you have to copy this example.
Done, sir.
Now see the working. The working is simple. Add the masses separately and add the uncertainties separately, and you will get the final answer. When you are adding the two masses, I repeat the concept, add up the numbers separately and add up the uncertainties separately, and in the end, combine them. You have to copy this screen.
Done, sir.
So what is the procedure? You have to add the numbers separately and add up the uncertainties separately. In the end, you can combine them in a single equation, in a single value. Now, rule number 2. Ariva, have you copied it?
Yes, sir.
Rule number 2, if u is equal to x minus y, delta u is equal to plus minus delta x plus delta y. What is the rule says? What this rule says? If two variables are subtracted, their uncertainties are still added. If two variables are subtracted, their uncertainties are still added. Now you have to copy this screen.
Okay. Done, sir.
So rule number 2 is there. When formula is there in terms of subtraction, you will subtract the variables. You will subtract the variables in its routine, but uncertainties are not subtracted as already mentioned in the start. Now look at this example. I have a ring and it has an external radius, it has an internal radius, and it has a thickness. The formula is there. Thickness is equal to capital R minus R, and we need to find the thickness. So when you solve such a question, the formula says subtraction. Now you
Yeah.
have to copy this screen.
Done, sir.
Now, this is a logic to understand that actually some formulas are made for addition, some formulas are made in subtraction. Uncertainty is not actually following the formula directly. Uncertainty has some of its own rules. Normal calculation will be done. So like R minus R, it will be 20 minus 11. This is fine. But what about the uncertainties? You will have to follow the rule that if variables are subtracted, uncertainties are added. Look at the first step. Copy the first step. Now, look at the second step. Delta T, delta is a symbol for uncertainty.
Yeah.
Delta R plus delta small r. uncertainties are not subtracted, they are added. In the final answer form, you have to combine them and you have to write them together. You have to copy this working.
Done, sir.
Good. Ariba, let me know once you have copied it.
Done, sir.
There are three main topics in this chapter, and this is, as a teacher, is our job to keep on reminding. Some topics are not important, some are very important. So in this chapter, there are three topics which are very important. One topic is uncertainty, then it's vector, and then it is base unit. Now we are moving towards next title, product. So give a side heading. Give a side heading, product. Give a side heading, product. Okay, now look at the term product. The first formula, deba xy, u is equal to xy. So when you are dealing with a formula in which two variables are in product form, you will add the uncertainties in terms of fractions. So you have to remember that in case of a product, you have to add up the fractions. So you have to copy this screen.
Okay.
Done, sir.
Now look at the example that how you will identify them in the paper. For example, area is equal to length into width. So you will write deba A upon A is equal to plus minus deba L upon L plus deba W upon W. Method is very simple. You have to convert every variable into a fraction. Numerator will be uncertainty and denominator will be the variable. So these are the two examples. You have to copy them.
So what would be the variable?
Variable means length, width, area, etc. These are called the variables.
Okay.
Have you copied it?
Yes, sir. No, no, sir. Once,
No problem.
yes, sir.
See the example, a very famous formula, P is equal to VI. When you write this formula, you must remember that the formula means power. Power is equal to voltage into current. Power is equal to voltage into current. So when you write the uncertainty, carefully see the method, delta P upon P. Then you will write a plus minus and open the bracket. Delta V upon V plus delta I upon I. This is how we write. This is a very important thing in our paper 2 and paper 1. As mentioned, uncertainty is the most important topic of this chapter. Now you have to copy this example.
Done.
Done, sir.
Okay. Now think of a formula which is also very famous, one of the most famous formula. F is equal to ma. What is this formula? What is this equation known as? What is this equation known as? F is equal to ma. Newton.
Then
Newton second law. Okay, now look at the first step. Look at the first step, delta F upon F. Then you write plus minus delta M upon M plus delta A upon A. Copy this example.
done, sir.
Done, sir.
Good. What is Ohm's law? What was Ohm's law?
Ohm's law is that voltage is directly proportional to resistance.
Very good. And what was the famous, what is directly proportional to current? Can you recall for me the formula, famous formula, Ohm's law?
V is equal to IR.
Yes.
Sir, 1 second.
Copy this. So can you help me to write down the follow-up of this equation?
Hello, sir.
how to write down the uncertainty equation for this Ohm's law?
يبقى V
upon
over
V plus minus deba I upon I plus deba R upon R. I have done three more, total 5 examples. So I think you got this. You must have gotten this idea that it's
yeah.
a way of writing the equations, breaking it into fractions, and the fractions are added. So copy this example also.
Done, sir.
Now we take a bigger example now. Now copy down this example. Copy down this example and try to solve it. I'm just coming. Try to solve it.
Okay, sir. Done, sir.
Let me try if you, sorry, let me know if you got any answer.
Sir, I got 300 plus minus 1/6.
300. Area is coming 300. Then use this formula. The most important thing is the movement of area to the right, because you need to find the subject. So you have to move it to the right side and then you have to put the values. Look at this calculation.
Sir, shouldn't the uncertainty be in a fraction, yeah?
Uncertainty is in fraction 2 upon 20. Actually, it's a fractional uncertainty. And look at the working, it is called fractional uncertainty. And when you put them in the formula and you move the denominator area to the right and solve, you will get the absolute uncertainty.
Okay, sure. Done, sir.
Yes, Aribet.
Done, sir.
Now, this is to remember that when you make these examples, you have to convert them into fractions. And when you simplify a fraction, you always have to make the target the subject. Subject making is something very important. Now, let's discuss it here. For absolute uncertainty, like for example, I take distance is equal to velocity into time, a famous formula for displacement. Now, when I take the formula, displacement is equal to velocity into time. Now look at carefully, delta d upon d is equal to plus minus delta v upon v plus delta t upon t. Now I want to find delta d. So I will move the denominator d on the other side. This shifting is necessary when you are finding absolute uncertainty.
And then you multiply with D.
Yes. Now copy this example.
Sure.
Done, sir.
This is our step for absolute uncertainty. And now you have seen this calculation. Now, see the formula number 4. If there are 3 letters in multiplication, formula approach will remain the same. You have to add up the fractions. You have to add up the fractions. You have to copy now formula number 4.
So what was formula number 3 again?
Rule number 3 was this product rule. Now, this
Yeah.
now there is a numbering issue. Now this is number 3.
Okay, sir.
Now this one number 4. This is actually a continuation of product rule. Now see the example. Volume is equal to length into breadth into height. You have to copy this example.
Okay. Done, sir.
Done, sir.
Now copy the data. You can note the values, wall length, breadth, and height. Copy the values.
Okay.
Now you have done the method and you know that how to write this formula. Remember, all multiples are converted into a fraction. All multiples are converted into a fraction.
Yeah.
Now find this formula.
Sir, is it 120 plus minus 10 meter cube?
120 plus minus 10. How come?
Meter.
First, you write down this formula.
Yeah, done it. It was initially 10.4, but then I converted it to one significant figure.
You can try that. Are you getting something in fraction?
I got 10.4. The fraction is 52 over
You're
5.
getting 10.4. Okay. Let's see if Ariba, can you also share your answer if you are getting an answer? What is this 0.1 upon 5 plus 0.2 upon 4 plus 0.1 upon 6 into 120?
I'm still doing it, sir.
Okay. Acha, Saad, can you please tell me what you are getting for Deba V after multiplying 120?
I got 10.4, but then I converted it to one significant figure and
You got
said,
10.4, right?
yeah. One sec.
Sorry?
One
Huh.
sec. Yeah, I got
10
10.
means one significant figure. Riba, are you getting the same value?
Yes, sir.
Okay, now formula number 5. It's a division. The rule is very similar, same as product rule. When two functions are in division, their uncertainties are in fractions and we add them.
Yeah.
Now you have to copy this screen. So it is the same rule as the product rule. You have to convert all of them into a fractional summation.
Yeah.
Now look at this example, copy this example. And try it. I'm just coming. I just have to say namaz. Asar is here. So please solve it and I'm just coming.
Done, sir.
First, compare density. Is it matching?
Yes, sir.
Okay. Density is 4. And then look at the working for density is equal to mass upon volume. And once we calculate the absolute uncertainty, what is the value of delta D coming up? Saad, have you calculated it?
Yeah, 0.2, sir.
Can you please repeat? 0.2.
2.
That's it, 0.2.
Yeah.
Is it no decimal after that? No place after that?
There is 0.18, but I converted to one significant.
This is what I was asking. 0.18.
Yeah.
Good. So when you write the density, you have a 4. So when you write down the final answer, you will write in this format. Okay, compare it and complete it.
Okay.
I have shared the books and there are 2 options available. Whatever is easily available to you, you should get those books. So we can start. Our first chapter is now nearly finished, but I have to give some time to this uncertainty. Otherwise, the topic is finished. So I just have to do relative velocity, which is a small topic. Now, the plan would be there that we should do some past paper work, and you can buy any book, any of the 2 books, but the book should be topical. So Ariba, did you get the same answer?
Yes, sir.
Okay,
Sir,
good.
sir, can we write 0.18 instead of 0.2?
That's a good question. But remember, uncertainty must be given correct to one significant figure. It's a rule. Uncertainty must be given correct to one significant figure. 0.18 means two significant figures. So you cannot write in 0.18.
Okay, sir.
Okay, thank you. Bye.
Assalamu
Thank
alaikum,
you,
sir.
sir.